Hey JSConf, how are you doing?
Hi JSConf.
How's the Wi-Fi holding up? All right, awesome. So yeah, welcome to our presentation on conference Wi-Fi redux. We're going to talk about how we try to, fix this Wi-Fi problem that you sometimes have at conferences. Let's start with a quick introduction of us two. So this is Meno. You might know him from on Twitter as Fast and Fearless. As a, there's a friend of him once described him as the only person in the world that can enter you in a revolving door one spot behind you and can exit before you. So be aware of this guy. And I'm Malte. And thanks for Brandon for the introduction. So let's start with a short voting. Who in this room has one Wi-Fi device attached to the network? How about 2? How about 3? Anybody 4? 5? The palm guy.
Everyone.
Nice. Awesome. So, yeah, right. So, I mean, Wi-Fi on conferences is likely to break, right? So we actually made 2 presentations. This is a web page, right? So we can now click on the right one, and we basically choose between everything's already not really working. If you're very familiar with us, you know where the photo on the left happened. But I kind of get the feeling we're in the better than Dojo department right now. So let's do that.
Yeah, we have a story to tell about the conferences Wi-Fi. Of course, it's very hard to make these. First of all, it is absolutely temporary. It's a setup that's made for 2 or 3 days. So you have to bring in everything, and you have to pick out everything, and you don't know exactly how the setup and the location are working. So it's tough. First of all, what's with the backbone? So you have no cables installed. We in this location we have, but in Germany we didn't have. So we have to build a backbone by our own. And secondary, of course, then the Wi-Fi. Of course, the frequency stuff is coming up, and we have to build a coverage of all the Wi-Fi spots, and it should work all around the area. And this is usually done in a longer setup in commercial environments. Out of these, it is a very complicated thing to think about a conference setup. Of course, you are crowded. You are sitting in one room. There are a lot of people. You need a lot of bandwidth. And first of all, you read what's on the Wi-Fi technical things, and you get the imagine there's enough bandwidth in the air. But that's only theoretically. In practical, we discovered we don't get more than 220 megabits through a room. And this sounds affordable and much, but it isn't. And out of these, we also learned that the bandwidth in the air is one thing, but there are a lot of other things to do with the back end and the connections to outside world and the internet. And out of these, we had a couple of strange things discovered with the usage pattern. Usually we would like to say, okay, it's just HTTP traffic, but it isn't at all. So that's all the learnings we had, and out of these, we tried to solve these.
Right, so basically in Berlin the situation was we was at this really nice, lofty industrial building. The problem was it didn't have an internet connection. So, we basically went the route of taking whatever you can get, right? So we ended up with 2 microwave radio, directed radio uplinks to the internet, and then we also bought 4 DSL consumer lines, which, as you might know, especially in Europe, they're asynchronous. They have much more downstream bandwidth than upstream bandwidth, right? And what you do is you do load balancing, right? So you have all those lines, and how do you get the traffic across? Yeah, that's load balancing.
Yes, and how do you done that? Of course, it's similar to HTTP, but it's in reverse style. So we have a link aggregation facility, which means, okay, on a web server, the requests are coming in from the internet, and they are spread out of your server cloud or server farm. And what we do is a different one. Of course, we get the packets from the conference, and we have to spread it out over the pipes we have to the internet. So, and then we have to rejoin them on another part in the internet. So this is done with link aggregation, and it's happening in both directions. So it's inbound and outbound traffic, which we observe. Out of these, the connections are asymmetric. So there's a lot of things to do.
We think this is the first implementation of this kind. So there's several other packages around that do this, but we didn't really find one. So it might be the first.
And the good thing on it is JavaScript, and it is written in Node. So it's
all traffic running over Node. What could go wrong, right?
Yeah.
Awesome. So we are introducing what we call sashimi. Sashimi is a packet knife, and it's written. It's using the kernel tune interface, which is exposing IP interfaces for the traffic on your external interfaces to userland. And what that gives you, and this is like the main part of Sashimi, it gives you a Node API to do userland JavaScript level IP stuff. We use it for link aggregation, but you could do all kinds of things, and you could also use it for like
packet inspection,
all kind of higher level things that could be done in JavaScript, and which you don't want to do in C if you're at a JavaScript conference. And to explain what Sashimi is doing, it's basically using TCP streams on those various connections, and is sending IP traffic, so whether it's TCP, UDP, whatever, over those TCP streams. So we're doing IP over TCP IP.
Between the both sides.
We need to go deeper.
Yeah.
Right, so this very uncomplicated picture kind of explains the situation we had in Berlin. So up there is the guy in the conference, and down here is the internet where you can download kittens, right? So there's two Sashimi processes. One is running inside the conference, the other one is running outside the conference, somewhere outside the conference. So we had on the left-hand side those radio links, two of them, and on the right side, our DSL connections. So we actually decided that because the DSL connections have so little upstream bandwidth, we don't want to use it at all for user traffic. We just use it for the confirmation packages in TCP IP. So what you see up there is from the upper Sashimi, the links going out, all outgoing traffic is going through the microwave links. And then it's coming back, and it's, the traffic lands on the Sashimi, you download the kitten. So you have the returning TCP IP packet. And right now, we're using all our links for the return. So it might very well happen, and I go out of the camera, but I have to, is that your packet is here, and it always comes through here, but it might go actually back through the DSL connection. So you can do full load balancing. And we have those multiple lines because we opened 4 TCP streams on these connections and 2 on these. And then we do round-robin load balancing on them so that you get twice as much traffic back through the microwave links than we see through the DSL connections. And it worked.
Yeah, of course we are on a technical conference, so we need some code. And this is about the packet streaming protocol. It's a general protocol. It's just have a header which say, okay, the packet will have the size of 1,000 bytes, and then the packet is transmitted. And in general, this is the code which is running in Sashimi, which receives data somehow, and further on, it receives the header, and then the packet, and then the header, and then the packet. That's why these active switches happening there. And the QAdd call does, we will have a further look later on the next slide or to it, it does just collecting the incoming data. Of course, the TCP fragments could be different to the sizes of the packets. So the calls which are coming in are given to the QAD, and the QAD say, okay, I now receive 4 bytes, for example, for the header, and then it calls a callback header complete, and header complete just switch around and sets a packet length for the next packet, and then the packet will be received. So with so the synchronization on a stream with a packet is established in somehow. The whole code is not much longer than these. It's a little bit tweaking around with buffers and having some offset calculation of the incoming buffers and thus the callbacks to all these things. So what you say, you drop in the data and you wait for 4 bytes and the callback is issued.
This might be a little hard to read, but Meno, he's one of those guys, he doesn't like semicolons. But I made him put them in there, so maybe we can get some learnings out of this. Anyway. Nice. So we talked about this one problem, that is that you kind of have those different connections and you solve that, right? So we experienced that other problem. Meno was talking about that earlier, and that is that people sometimes do weird things on the conference Wi-Fi, and you wouldn't really expect that. It's you back up your stuff, and we're experiencing that's actually right now. People do have backup agents running on their computer, and they're constantly pushing traffic into the internet, which is absolutely different from what you would expect from somebody checking Twitter, right? So what happens is we experience this congestion, and what do you do if you get congestion, right? So on the first JSConf EU, Meno was sitting in this corner the whole time and was inspecting target IP addresses, trying to block them. So what we experienced actually 2 weeks ago is that basically 90% of the internet runs on Amazon, right? So once you discover that those guys are all backing up their stuff to Amazon, and then you decide to block Amazon, you block the internet, basically, right? So you can't do that. So, and it's 2011, right? So what do you do if things are broke? You need to add more social to the experience. So you might have noticed that you guys had to make a Twitter OAuth connection to get on the Wi-Fi. So, and we were pretty clear about on the page what this means. That means that you guys aren't anonymous anymore, right? If we see that one of you guys is sending out huge amounts of traffic through the internet, we're going to come back to you and tell you, please stop. Because before that, we just had an IP address and we didn't know who it is. So now we know, right? And so coming from this, we actually, we have all this data and it's associated with Twitter names. You can do fancy things, like on the next page.
You must work at Google.
He does. Obviously, he does.
I didn't mention that on purpose.
And I help him.
Right. So he's the evil guy. I'm just
he's a good guy.
I'm just a search engine.
Okay.
So let's look at this. Here, it doesn't start out to be very fancy. So this is an application that we call social traffic. You can actually see it now at social-traffic.streamy.org. And the first graph is showing you the overall traffic that went through the pipes of this conference throughout the time, right? Can you move on to the second graph?
Yes.
This is showing you the short-term traffic. So this is actually the last 3 minutes, what went through the pipes. It's kind of a weird unit. It's bytes per 10 minutes, but it doesn't really matter, right? So moving further down, we see actual Twitter names associated with the traffic that they pursued. And it's very interesting. Stay on top, stay on top, stay on top.
Okay. That's outbound traffic. I want to go to the
No, go there, because there's a new thing.
Yeah.
Because, Fast and Fearless and Krampus, our Twitter names, right? We were on position 1 because we were, we were testing this. But who is JSConf?
Whoa. Bad guy.
Bad guy, way to go. No. What did you do? Demos? That's a pretty good excuse. You uploaded 1.3 gigabytes of demos to the internet. Awesome.
do that.
Let's go to the outbound traffic.
So you see all the names are in that. It's a long list. It's around 260 users we discovered.
Let's talk about a little how we built this. So whenever you go through the sign up OAuth.
Oh, you are first. So it's fine. You're still the first.
Oh, awesome. Is this outgoing or inbound?
Inbound.
I see. So let's talk about how this works. So you go through the sign up process. We open up IP tables for your MAC address and store in a CouchDB what your OAuth token is, what your Twitter ID is, what your username, and then we get those flow packages, flow files from the firewall, and we associate them back with your Twitter name and write all of that into a CouchDB. So don't worry about it. We don't actually store the payload data, which would be kind of hard, but we do store the amounts of bytes that you're sending in and out of the internet.
He's a good guy from Google.
Right. So then we sync that database outside of the conference to a data center using CouchDB replication, and this application is actually just a HTML file that's looking at that data. It's on GitHub. You get the URL later, and you might have other fine ideas what you could do with that data if you get it.
Yeah.
I wanted to see other people, right? So Spoon. So this thing, what we didn't show yet is you can actually click those names.
I can do that. And then you will see in the graph, of course, I switch off the all inbound and all outbound traffic. Oh, I'm one too high. He doesn't. Oh, where's that gone?
Maybe it broke.
It broke? No, it doesn't. It doesn't. I don't know.
Interesting.
It's interesting.
Let's use somebody else. Maybe Spoon is evil. What's up with this guy?
That's me. It's also gone, so we are not here.
So
Huh?
It's probably the CouchDB that's down. So anyway, we can Jan. We're gonna fix that. It's on the internet. Maybe it works for you. So one last thing, right? So there were some comments already about that in Twitter. You guys all gave us your OAuth write access to your Twitter account, right? So what we want to do now is the largest mass pooping in the history of the internet. Please check your internet. Actually, we didn't. Well, we could.
But we could. He's a good guy, I'm the bad one, of course. So
we flipped the coin and we decided not to. We should still do this world record. Maybe when everybody is up here tonight, and but everybody does it on his own will. So anyway, really,
yes,
that's it. Oh no,
no, it isn't. It isn't. Of course, we have to mention where we are put all this stuff. First of all, it's a bit pre-alpha. No, it's not pre-alpha. It's tailor-made for conferences like these. So you can extend it, but don't expect that it is completely done and everything is in. The first of all is Sashimi is on my GitHub account, and the social traffic stuff from Cramforce you will find on his one. And it would be nice if we get some pull requests for the social traffic stuff, or Sashimi, we will integrate that, and we will see where it's working the next time. There are a lot of ideas to deal with all these information.
It's really interesting. Once you have traffic and identity, you can do interesting stuff with it. And who knows what's going to happen?
Yes. Thank you.
That's it. Are there any questions? This is the on the plane the test setup.
Of course, on the plane you don't allow to enable the Wi-Fi, so we choose a cable, and it works. Okay. Here for the Wi-Fi access points, or where? We have a lot of hardware. The hardware here around is from. Oh, We didn't install it here, but
Right. The actual Wi-Fi routers are delivered by a vendor, so it's not our business.
in Germany we will have by our own.
And so there's a Foxconn computer. You probably know more about it.
Yeah.
Running inside this conference.
It's a very small system which just collecting the data and does the backbone routing. That's all. Another question?
More questions?
So, okay. Thank you.
Thanks.
Laura, did you remember to load the bacon?
Oh, I knew I forgot something.